watched my episode on DataStax Accelerate about the future of Cassandra and Kubernetes. And it was a short episode for sure, 30 minutes, but it got the point across, I hope. Well, there were longer interviews that happened, of course, and one of those was with Raghavendra Prabhu from Yelp. Now, if you want to have an opinion about something, it's really important that you've done the work, and he's done a lot of work. They've been doing Cassandra and Kubernetes for a couple of years now, and they have a system called PaaSTA, which is really kind of interesting, and if you have a chance, go check it out. But part of that conversation was more about the future of databases too. So I wanted to make sure we captured the entire conversation. He has some fun insights on how operators should work, and I think you'll enjoy this conversation. So here's the long form version.
Hello, this is Raghavendra Prabhu from Yelp London office. I work here as a senior software engineer. And the team I work in is database and reliability engineering. And in our team, as the name implies, we deal with the databases, which include MySQL and Cassandra. And so since we are speaking about Cassandra specifically, let me go over some of the things that is powered by Cassandra at Yelp. So what is Yelp, first of all? So Yelp's mission is to connect people with great local businesses. And that includes things such as good, high-quality reviews, features such as Yelp reservations and waitlisting for restaurants. So wherein you can wait for in a restaurant queue virtually, and then you also have you can also access a lot of local services such as a plumber, and there are also features such as request a code. So some of these things power a lot of our traffic to Cassandra, in addition to some of the internal traffic for which we use Cassandra for things such as Zipkin or for caching.
That's a lot. Wow. And just curious, I know you have a lot of services going on. How's the COVID-19 situation for you? Oh, well, for Yelp. It's changed, I'm sure, right?
Well, yes, of course, nothing stands in isolation, I guess. But I'm not sure if I can comment on the financial side of things for
No, we'll skip that.
Yeah,
we could skip that. Yeah, I just know that I've been using Yelp a lot to figure out who's delivering. Yeah.
Yeah, I believe we have added some features on that front now. Yeah, always good to adapt, right?
That's it. Yeah. All right. So we'll jump right into the Kubernetes stuff. And I'm really happy that you're here. This is going to be interesting. So we'll start out with just a general question. So Kubernetes seems to be the choice that people have made, organizations have made for deploying applications, the application tier. Why do you think that is?
Sure. I mean, if I have to pick some from the top of my head, I would say that one is first of all, I guess this does not escape anyone, but it has a very active and vibrant community containing not just from the open source community, but also like a lot and most of the major cloud providers, Google, Microsoft, and Amazon. So there's a significant accretion towards Kubernetes, both from the industry, behemoths, as well as the open source community, and that's very useful. Second, it's also quite extensible, and this is kind of something that applies to people who have like mature infrastructure setups, with their own passes like us, and the choice of language is also contributing towards this, and that also. And more importantly, one more thing I would like to add here is that it also supports multiple and diverse use cases. But by that, what I mean is it has a very good support for stateful applications. Now imagine, let's say there was something. Let's say you picked something else, let's say something X instead of Kubernetes. And while it may have a good support for stateless applications, you cannot imagine an organization having two of them, right? One for stateful and one for stateless. So it's always good to have something which supports both stateful and stateless applications in a good manner. And I think Kubernetes fits that bill really well.
So, databases have been following, databases have been behind in what's happening with Kubernetes and is just now catching up. But what was going on with databases, say, a few years ago when Kubernetes was becoming the thing for application?
Sure. I mean, databases, I think, over the period have become more and more, how should I say it, become more manageable in a zero configuration kind of way, which is very useful when it comes to deploying on something like Kubernetes. Cassandra, I mean, to start with, Cassandra itself is quite good in that way, because it's kind of like a symmetric setup, right? You just add more nodes and it just grows. I saw a tweet from your CEO today morning, where he compared it to peanut butter and jelly. So and that was interesting. So I mean, things like not relying on anything static, and becoming more amenable to like what I would say is fallacies of distributed computing. Have you heard of that? 12 fallacies.
Yes.
Yeah, sure. Okay. So if any database which kind of does not depend on too many snowflakey kind of configuration, for when you're deploying, make for good use cases for Kubernetes. Before working at Yelp, I was also working on Percona XDB cluster at Percona, which is a Galera cluster, which is for MySQL, something similar, like a synchronous replication with a kind of a symmetric setup such as Cassandra. And over there also, I prototyped Kubernetes, and this was a way long back when stateful sets were called as pet sets, and that was quite interesting as well. So I think for databases like Cassandra, which do a lot of heavy lifting in form of gossiping and dynamic topology updates to clients and snitching and stuff like that, there is a very good future for for deploying them on Kubernetes and getting most bang a buck.
So great, and it's where we're at right now. I think that we've gotten to the point where most of the database people who run databases have come to the same conclusion that, hey, this is a good idea, but now, and just like anything else in open source, we now have a lot of operators. And you work on an operator. So do you think there's a place for a common operator, or do you think there will always be multiple operators?
Sure. Yeah, so speaking about the operators for databases in particular, I presume you mean for like Cassandra.
For Cassandra,
right?
yes.
Okay, right. Yeah, I think for like anything smaller or for new infrastructure setups, right? Anything who's starting new with Cassandra or has a Cassandra setup which is not tied too deeply into their infrastructure or has any dependencies which are specific to their infrastructure. I think any well-supported operator like the DataStax operator can go a very long way and probably do everything that they need, right? But for larger and old and more mature setups, right? Like something like, I mean, just to give ours, just as an example, infrastructure tends to be quite opinionated and idiosyncratic. By that, what I mean is, like our Cassandra, like the general non-Kubernetes Cassandra uses like HA proxy, and Synapse a lot for how things are discovered and things like that. We also have multi-region Cassandra setup, and when it comes to Kubernetes itself, how Kubernetes is not federated, so it is non-federated. So there is a Kubernetes cluster per region, but our Cassandra cluster is multi-region. So we have to do some extra stuff like locking and stuff like that, in addition to other things when we are doing some deployments and so on. So things like that, which are probably not used anywhere else, but are specific to our organization. So I think in that way, I think for us an operator is quite useful. Having our own operator. But at the same time, anyway, coming back to your question again, I think even if there is even if there are multiple operators, if they do share common building blocks, like the management API of DataStax, which you released recently, which we are planning on using, and things like operator SDK. It's possible to have multiple operators, but at the same time, keep them. They don't have to duplicate much of the logic, and keep something. Only have the stuff which is specific to the infrastructure in that way. So yeah, so just a TLDR is for anything which is not which does not have a very opinionated infrastructure or their own platform as a service like we do. I think a common operator like a DataStax operator will be sufficient for them 99% of their use cases and for everything. But for setups such as ours, where we have our own platform as a service which we need to integrate into, we may need a separate operator.
So, and I think you have a unique position here. Like, what do you think are the most important parts of a Kubernetes operator for Cassandra? What has to be there?
Sure. So when I think of the operator, when I think of the Kubernetes operator, I usually think of it as like a proxy for an actual human being. Like someone in the operations team, but like a robot, but running as a software. So in that way, if I think about it, the first thing that comes to my mind is safety. What I mean by that is like whenever whenever the underlying nodes, they die, or new nodes join, the actual hardware nodes, the operator should be able to like handle lifecycle management of the cluster, and scaling the cluster up and down in a seamless manner. I would say that's the first thing that that's like the primary need. Uh, if that, and everything starts from there. So the next thing is, and this is something that's very exciting for us as well, which is to scale cluster up and down, based on load, for instance, because load tends to be cyclical based on where the sun is, and also other thing which has been very useful to us is that operator, again, as it comes, this is like a robot, right? So it should always have a way to it should always have a fallback in place, so it should be able to do critical operations, such as decommissioning the node. But at the same time, if it's not sure, it should always have a fallback for human operator to step in, which means that there should be a way for a human operator to come in when intimated by any signal from this operator, to pause this operator, to pause the Kubernetes operator and do things yourself, and then resume it. I think that's very important, and that's something we have been able to do that because in PaaSTA, where we deploy this operator, we can just do PaaSTA stop Kubernetes operator, do whatever we want, and then do PaaSTA start, and operator then reconciles its state and proceeds. So that's something I would consider to be a very useful thing as well, because many a time before, this is not restricted to Kubernetes, but many a time it has so happened that we have some automation, and the automation is doing something wrong. Like, I mean, it's doing something, but there's no way to stop it, and you also have to go and fix it. So it's always good if an operator, you can stop an operator, do something. I mean, there are things things can go in a wrong direction, and so I think that's always useful. And the last thing, I mean, there are more things, but one other thing I want to add here is the deployment safety. Because with the operator in place, you'll have your cluster in the continuous integration deployment pipeline, right? So you need to be able to deploy things safely and in such a way that if something is not good, it does not end up deploying to all the other clusters. Most of the organizations will have like a lot of clusters. Like we have like 10, 15 clusters. So we don't want, like, if we are pushing some package update, we don't want it to break everything. If it breaks on first one. So that's something which I would consider very vital.
Yeah, and I love your analogy that an operator is a robot. That is perfect. Yeah, and I think that's a really great way to explain it to people. Because, like, what is an operator? Is it it's just think of it as like a robot running through your data center.
Yes. Yeah. Yes.
And it needs good input, and it needs to be able to, it needs access to things to change. So yeah.
Yes.
So let's talk about the future here. So a potential future where all Cassandra workloads are running on Kubernetes, and that robot is enabled and has can do a lot of really cool things efficiently and with safety, like you said. So what are some of those new use cases that now open up for Cassandra?
In terms of use cases, do you mean like, so use cases with the future of Cassandra running in Kubernetes? What do you mean? Like, can
like
you give
a
me
new use cases? Like right now, you're using it for transactional workloads. And,
sure.
And I'm sure it's for a lot of mission critical data, but what kind of new use cases? And, we're just guessing here, like some new use cases that could come, that if you have an easier to run Cassandra, what else would you use it for?
Okay, that's an interesting question. I mean, we have been using it for like pretty much like a lot of the metric stuff, for some caching stuff internally. I mean, yeah, that's interesting. But in addition to thinking about use cases, like some of the things that would change your way of thinking would be like how you think about deployment itself, is what I would say. Like when you deploy now, instead of thinking about like instance types or how many nodes or something, you think about number of CPUs, number of how much memory and how much disk you need, So your questions that you ask, that the questions that you frame when you are deploying something can change according to that. So you'll think about CPUs, memory, and disk. And also, and this is something which is very important to us, it also helps us in thinking better in terms of cost, So what I mean by that is, like when you deploy an EC2, you have a lot of system processes, and you have then you have the Cassandra running. You can use C groups, whatnot. But with Kubernetes, you can reframe your questions in terms of things like what is the cost per CPU, or how many requests per CPU, or what is cost per request, things like that. So if you can better frame that way, right, you can make better cases. And coming to use cases itself, you can make better a bargain with the management, when you are introducing something new, because now you'll have some very concrete numbers on, let's say this cluster needs to take 1,000 requests per second, you can say how much cost you can attribute to that, and I think that's going to be very useful from that point of view. And yeah, I think yeah.
That's interesting. I had not thought about that too, that aspect as well. But yeah, if the operator is the robot and you give the robot a task, here's all I need, find the cheapest way to do this.
Yes, like a bill of materials, right? You give like a bill of materials, and it tries to come up with a very good optimization for how it needs to be deployed. I mean, we have also been internally discussing this on like you always also need a fleet manager, right, which does like the right bin packing and all stuff like that. So if you can optimize on bin packing of these Cassandra pods in the most optimal way, you'll be able to extract a lot more from your hardware, and I think that's very vital.
Yeah, that is the most different answer I've heard so far, and it's really interesting. And it's also the most interesting. I think I've heard a lot about machine learning and new pipelines or smaller use cases, but I appreciate that point of view.
Sure.
And being an operator, someone who has to get out there and make this thing work at the lowest cost possible, why not let a machine do that?
Yes. I mean, doing all this math of bin packing, what's the best way to pack in our head is not possible, or even on paper. It's like a NP complete problem, right?
Right.
All the knapsack problem. It's kind of like the knapsack problem. So it's always good to use, computers for what they are good for, I would say,
Yeah.
and ensure that, that they can pack things as efficiently as possible. And I see there are a lot of these companies doing some innovative stuff, precisely because Kubernetes is extensible. So a lot of vendors can do things on how you can best do Kubernetes scheduling, for instance, things like that.
Yeah, that's a really good point. Efficiency built into Kubernetes. I mean, Kubernetes can save you money. Let me show you how. Well, is there anything else? I mean, things that you want to talk about here? I mean, we have a few minutes and we could talk about whatever. Those are my 5 questions. And
Sure.
I mean, are there things that you would want to bring forward, or something interesting that you want to talk about? I'm just happy I have you on here, so I'm going to take advantage of it.
Yeah, sure. I mean, I was thinking like now seeing it from the other side. Well, we were talking about Kubernetes, but from the Cassandra side, I was thinking like, are there any things that you're planning to add to Cassandra to make it more, Kubernetes or cloud container friendly and things like that, And like some of the things I've been thinking like, while using this, where things like, are there any better ways you can, for instance, like detect like memory pressure or things like that, and use snitching to reduce imbalance, if you know what I mean, like dynamic snitching and stuff like that too. I mean, when those things were introduced initially, I guess they were not introduced with containers in mind, right? So I was thinking, are there any things you are planning, since you're the Cassandra guys, anything from that point of view?
Well, it's interesting you should mention this. There's a lot of discussion right now, especially on the mailing list, about should the Cassandra project sponsor an official Docker image. But where the discussion is going is, Docker has, because there isn't just one Docker image for everything, that it usually is a reflection of your infrastructure. I mean, what's your opinion on that? Do you think there's a single Docker image, or what makes a good Docker image for Cassandra?
Okay, that's well, in terms of Docker image, well, I mean, it's just a package, and I guess some good things, right? Like some things which you think are good to run Cassandra with, right? I mean, I don't know, maybe like jmalloc, for instance, which you recommend, but not necessarily be present in the Docker image. So maybe things like that you can probably add, I guess. And in terms of configuration, I don't know, like if it depends, like what's the default configuration that comes with Cassandra, right? As a package, if it would be good to evaluate if it's good for running from inside the container as well or not. And also the Java version, because Java, I think till Java 9 or so was having issues while running in the container, right? Now, I presume Cassandra for Java 13 or
11.
Java 12 or 11, right? Right. So I think that's an important thing as well. Because prior to if you are running Java 8 with Cassandra in a container, you're probably seeing some issues, which is not desirable, right? So from that point of view, I think that would be good. I feel a Docker image, but in addition to that, I was thinking like I mean, in terms of settings themselves, like if there is anything like from the failure detection or anything from those points of view, or in places wherein just to give you an example, so when there is like a memory pressure for a container, it readily ooms, right? So like a Java, the container readily ooms, but if a container is under CPU pressure, right, there is no ooming for CPU, right? It gets throttled, right. But it's kind of silent there. It's what is termed as like a gray failure, and while you can have some metrics for that, but at the same time, I think it would be good if a database can kind of react to that and see if it can rebalance its load or something like that. I mean, I'm just thinking on top of my head here, but I mean, this is just I'm just trying to reframe the question from other side, which is that while Kubernetes is doing a lot of things, while they're doing a lot of stuff for running stateful workload, and with CSI drivers, and I also noticed Kubernetes 1.18 has support for NUMA, for instance, which will be very useful for Cassandra. And and that would be something I'll be very interested in looking at. It's also good to see, like, to see from the Cassandra point of view and see if there are what can you add to make it more more container friendly. I mean, maybe there are not many things, but at the same time, it would be good to see from empirical studies and so on. That's just that's just a thought. Yeah.
There's one thing that might be interesting there. You mentioned, like, what happens whenever the CPU goes to 100%. Well, usually there's some sort of user action that does that. And as someone who has to run a lot of Cassandra, that it's difficult sometimes because you don't know what your users are doing. They could do things that are like, that's causing more problems on the cluster. There's a lot of talk. DataStax has been working on our project, but I think this is something that will show up in the open source side, is guardrails, putting boundaries around things. And it's how many indexes you can add to a table, or the types of queries that you can run. There are already some guardrails in the system. You may have already seen, like, whenever you use a batch, it'll throw an error or warning if there's like a sizing problem. That shows up in the user log, though, or in the system log. But guardrails as a concept, a database that protects itself now.
Right. Yeah.
What do you think about that?
Oh yeah, that's kind of like where I was going, actually. Yeah, and it's good to, is this something public, or is this going to be public, the guardrails that you mentioned?
It is currently in DataStax Enterprise 6.8, and it's like a preview version of it. But yeah, I think there's enough folks in the open source community that are also saying, yeah, we need this in Apache Cassandra as well.
Oh, wow. That would be great. Yeah, that's precisely what I was kind of hinting at, because I think the opportunities for, like, I mean, rather than opportunities, but let me put it this way: the cases wherein those guardrails will be useful will be more now that you're deploying in something like Kubernetes, especially depending on how much you are, trying to, what's the level of cohabitation of these Cassandra pods with other things, things like that.
Yeah. That's I think that goes along with what you're saying. It's like the container has to also do some things to work well in Kubernetes. You can't just expect Kubernetes to do all the work.
Yeah. And I mean, I was also like mulling things like, I mean, I'm not sure if Kubernetes has this now. I think it does, but in Kubernetes, when you provide CPUs, it's just amount of CPU shares that you need with the completely fair scheduler of Linux, right? Now, but I was thinking like, what's the best way you can ensure that Cassandra is, for instance, using like just like isolation of the CPUs, like it does not provide isolation when you give CPUs in Kubernetes, like using CPU sets equivalent of that and seeing how that goes. Because otherwise what can potentially happen is if you deploy, let's say, Cassandra with a lot of other things, maybe on like a system with 72 CPUs, right? And maybe like just to give like 512 gigs of memory, 72 CPUs. So there will be a non-uniform access involved. And that's where I think Kubernetes 1.18 will help. But there are few more things to think about there, which is that once things can get scheduled back and forth between the CPUs and the impact on the cache and stuff like that, So there are a lot of things, but I'm not sure. I don't think this is something Cassandra as a database needs to look at, but this is more from the deployment side, something to think about. Because there is a potential for a lot of thrashing and stuff like that, and this is more important when it comes to something like Cassandra rather than like a stateless application, because databases are where you burn a lot of rubber, right? You burn a lot of CPU memory, everything. So that's where you'll start hitting all these boundaries, I would say. And
that's the NUMA changes. Yeah, so if we can do something like CPU set, task set, which allows us to not flush L2 and L3 cache every single time we do a context switch, that would be great.
Yeah, and hopefully, I think the Linux scheduler has improved leaps and bounds now with respect to NUMA and balancing it. But at the same time, it would be good to evaluate. I mean, if for Cassandra, for instance, we do use NumaCTL, but when it comes to deploying on like Kubernetes on like in a containerized setup, I'm not sure if Kubernetes specifically looks at things to avoid. I mean, I don't think it's Kubernetes which can do that, but it's the Linux containerization, whatever the logic, to ensure that the processes are not bouncing across sockets and stuff. And that can hurt the performance.
Well, that's the cost. I think that speaks to the cost that you're talking about. It's not, the cost isn't just always in money. It's also cost in resources. How much resource? Well, and eventually it turns into a money problem. But if I can do things more efficiently, how can I redirect my databases into a correct area, or pack them properly so that that CPU is being used as best as possible?
Exactly. And I think, if you frame it as requests per CPU or something like that, right? And if you use that kind of thinking, like how many requests are being served by one CPU, right? That's where I think that math will be useful, that calculus, because that's where you'll see whether you're extracting the most from that CPU or not, stuff like that.
That's interesting. It almost makes it sound like you're advocating for Ingress to be involved in this as well.
You mean Kubernetes Ingress, right?
Yeah, Kubernetes. Like if Kubernetes Ingress was aware of the Cassandra nodes behind it. Let's say you're using something like a service mesh, like Istio,
right?
And your requests are going around the cluster. Is Istio having a cluster aware Istio? Is that an interesting thing?
I'm not.
That's something to think about, isn't it?
Yeah. Certainly. We don't use Istio. I mean, we are still, I believe, in the initial stages of Envoy integration and so on. But yeah, maybe I think that would be good as well. Yeah.
Well, when you brought up the request per CPU, that's going that's also going to be attached to a partition key, which will give you, what CPU, what partition, which node in the cluster, and all that's baked into the request.
Oh, right, nice. Okay, that's good to know.
Well, the Java driver is smart enough to know, oh, well, I know where this, because of the partition key, I can hash this and I know where to ask. It doesn't just do random hops. It is more intelligent about it.
Oh, wow. Yeah, right. Is that something that is there in the Python driver also, or is this specific to Java driver?
Every driver should have that. Yeah.
Okay.
It's a token awareness that's built into the driver itself.
Oh yeah.
And when it connects to the cluster, it's participating in gossip, so it knows where what all the nodes are, what all the token ranges are, and so whenever it makes a request, it knows which nodes to go directly to.
Oh yeah, we do use token-aware routing. Sorry, I didn't know you were referring to that actually. So yeah.
Well, I'm saying add the token-aware routing into the service mesh.
Oh.
Aha.
Oh yeah, that would be quite interesting. Yeah, I agree.
All right, we just brainstormed that. That just happened. So I'll have to make a Jira for that. All right.
Sure. Yeah, I mean, the other thing that we have been looking at was the snapshot management of Cassandra, like in particular with the CSI drivers. CSI drivers so we are using the AWS EBS driver, storage driver with Cassandra Kubernetes and even now we are using the internal one, which comes with Kubernetes, but that's deprecated because all these drivers are moving out of tree. And AWS EBS have their own out-of-tree driver now, and which provides things like snapshotting, which we are using. Snapshotting is there in the old driver as well, but something we are experimenting there with respect to restore and so on. So.
Yeah, the backup and restore.
Yeah.
Never goes away. It's always it's the always operations problem. I'd rather have a robot do that too.
Exactly. Or in some way like something in the container, or like a cron job running in the container or something, or even something external.
Yeah, it's interesting. A cron job in a container. I like the external idea better. Yeah, something central, but yeah. That's interesting too. Boy, I mean, good stuff.
I mean, that's been something of a philosophical debate in between our colleagues about whether to put something into the sidecar or not. Like if you put something in a sidecar of a Cassandra pod, if you make it a sidecar versus putting it on the host itself, it has different implications. Particularly from the resource usage point of view. Like if you can run something one per host rather than one per pod, it's the number of CPUs multiplied by number of pods, right? So, so quickly your cost can go up. So that's something to think about there.
Well, resource management in general is hopefully what we get out of Kubernetes. Like you said, like the bin packing algorithms, the replication controllers, that kind of thing. And it's interesting to see that Cassandra what Cassandra could bring to that is it doesn't really need a lot of replication management. It just needs to be aware of what's happening from a pod. Like, where am I? Do I need to replicate? We're like, if the entire cluster is sitting on one physical node, you may have problems.
Exactly. And to think along those lines, I was also thinking can you make Cassandra more, how should I say it, more understandable about getting evicted? Can you tell the Cassandra node that, this node is going away soon, like maybe in 2 or 5 minutes, or maybe 2 minutes, do all the things. I mean, we do like drain and stuff, but is there anything more that we could do there, was something that I've been thinking.
It's like the operator know, like, hey, by the way, this is now going offline, or we just issued a shutdown.
Yeah. And this is more, I'm not sure about other deployments, but we have been experimenting with deployments on Spot Fleet, for things like wherein we can, do away with the possible, loss of one replica, because when we use multiple of replication factor, things like for metrics, for instance, or for Zipkin, we have been experimenting with spot fleets. And with spot fleets, what happens is Amazon gives you a time window of 2 minutes. It says, oh, this node is going away in 2 minutes. Do whatever you have to do. And,
that should be plenty of time. Especially if you have a snapshot on EBS.
Yeah. It is for us, but I was again trying to think whether is there anything, if it is known even slightly ahead in advance, is there anything else that can be done? Recently we tried to decommission, scale down from 8 nodes to 4 nodes, and we usually our operator logic goes in such a way that we do it one at a time. We do one, we go from 8 to 7 and we check everything is fine, then go from 7 to 6. And the way Cassandra redistributes its data, we were just wondering, can we mark it so that, can we tell the cluster that we are going from 8 to 4, in some way that it does not involve a significant churn of data. Like that. This is more from a horizontal scalability point of view.
Yeah. Now, if you tell it to go from 8 to 4, well, if you shut down, decommission 4 nodes at the same time, that's what you're going to do. Sure. But there's I think the order, that's definitely sounds like something more in the operators world, where it's I'd like to, if I say I do a kubectl deploy scale equals 4 and, change my scale, then the operator should be I know what to do, and go do it in a way that's orderly and does it in a way Cassandra can deal with it fine, instead of just shutting down 4 nodes, which it would do if it was Nginx, just turn them off. There, fix the problem.
Right.
And then you have a cluster with half the data just all of a sudden missing, so you're going to be running repairs at that point.
Yeah, exactly.
Yeah. That's a good point.
This is how our decommissioning looks like. We, as I said, when going from 8 to 4, we do one at a time, because we don't want to cause some sudden changes in capacity, for instance, or things like that. And at the same time, we kind of we have a readiness check, the whole stateful set readiness check and ordered thing we use. So since it's a stateful set, it comes from n-1, right? So the last port and so on. So this all ties back to the safety and the robot kind of thing. All of this happens when we are sleeping, and we don't want to, ideally, things the cluster can scale up or scale down, or nodes can die in the middle of the night, and that's where it all ties back to the safety. It should be able to do it in a safe way and in a fully deterministic way. So we have a lot of checks and balances here and there to ensure that the operator doesn't do something if it's not sure.
I love that philosophy. Thanks for joining us, and I hope you enjoyed the entire conversation. As you can tell, Raghu and I had a really good time talking about Cassandra and Kubernetes, and I hope we get to do it sometime soon. He was supposed to be presenting this talk at Accelerate if we were going to do it in person. So I'm really happy that we were able to pivot and turn this into an online thing during the COVID-19 crisis. And I think having him on more is going to be great for the community, because his insights are really good about how to run Cassandra and Kubernetes, especially in a cloud environment. And some of his insights into things like cost savings are really cool, and I haven't heard anyone talk about that yet. So once again, thanks a lot for joining us, and we'll see you next time.